We're now going to look at expanding expressions which are perfect squares. But before we do this, let's look at what perfect squares are. Perfect squares are numbers like 1, 4, 9, 16, 25, 36, 49, and so on. Now you'll notice with each of these numbers, we have a number multiplied by itself to give these numbers. So for example, we have 1 times 1, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. And 7 squared is 49, and so on. So therefore, these numbers are perfect squares, and that's what perfect squares means. So if we apply this idea here, you can see that x plus 4 is inside a set of brackets, and they are multiplied by itself. In other words, x plus 4 squared. So we're now going to have a look at expanding these perfect squares. Now, what this means is I can rewrite x plus 4 all squared as x plus 4 times x plus 4. And then we can just expand how we normally do it, where I go x times x, x squared, x times 4 is plus 4x, 4 times x gives plus 4x, and then 4 times 4 gives plus 16. I then collect the like terms of 4x and 4x, so we get x squared plus 4x and 4x is 8x plus 16. Okay, now that is one way we can do it. There's also a shorter way which we will look at in a minute. Let's now do this one here, x minus 3 all squared. Now again, I can rewrite this as x minus 3 times x minus 3. I can rewrite it like that, and then expand them how we usually do it. So x times x, x squared, x times minus 3 is minus 3x, minus 3 times x gives minus 3x, and then minus 3 times minus 3 gives plus 9. Now we collect the negative 3's here, so we get x squared minus 6x plus 9. Okay, now we're going to have a look at a shorter way here. Now I want you to see if you can see a pattern we can actually apply to expand these perfect squares much more easier. Now you'll notice here, if I just square the first term in there, so I square x, I get x squared. If I just square the 4, I get 16. So we can find the first and last terms in our expression very easily. But how do we get this 8x? You'll notice that if we multiply the two terms inside the bracket, so 4 times x gives 4x, and then we double it, we will get 8x. So 2 times 4x is 8x. Now that is a quicker method. Here, if we have x minus 3 all squared, let's use the quicker method. So if I square the first term, I get x squared. I square the last term, which is negative 3 times negative 3 will give plus 9. And as I said before, they give the first and last terms in the expression. Now to get the middle term here, we multiply the negative 3 times x, which is negative 3x, double it, we get negative 6x there. And that's the quick way. So now let's have a look at this, the general form now. If we have a plus b all squared, I can square the first term and get a squared. I square the last term and get plus b squared. I then multiply the two terms inside the bracket, which is AB, so we get A times B, AB. Double it, I get plus 2AB. And I'll highlight that. That is our general rule. When we have A plus B all squared, we'll always give A squared plus 2AB plus B squared. Now let's do the same thing here to A minus B all squared. We square the first term, we get A squared. We square the last term here, the negative B times negative B gives plus B squared. And now we multiply the A times negative B and we get negative AB. Double it, we get negative 2AB. And this is the general form there as well. Now let's just do two more examples here. If we have x plus 6 all squared, let's expand that. Let's use the quick method. Square the first term, we get x squared. Square the last term, we get 6 times 6 plus 36. Now we multiply the 6 and the x and get 6x. Double it, we get plus 12x. Let's do one more here. We have x minus 8 all squared. Now I square the first term, get x squared. Square the last term here, which is negative 8 times negative 8 gives plus 64. Now here I multiply the negative 8 times x and get negative 8x. Double it, I get negative 16x. And that is how we expand perfect squares.